Right, factorizing of factors, getting the factors. This is just an overview of all the different types of factorizing that we can use and that you must be able to do. And then after this overview, I will have different videos explaining each one of them in more detail. The first type of factorizing that you get is taking out the highest common factor. Now this is where, say for instance, I have 3x squared plus 6xy minus 12x, and I take out a highest common factor 3x, leaving me with x plus 2y minus 4. Right, this is the procedure I call taking out the highest common factor, and this is the first type of factorizing that you must be able to do. The second type of factorizing is difference of squares, which is a basic rule that you need to know. If I have the difference between two squared numbers, it's literally what it says, difference of two squared numbers, difference of squared numbers, then this factorizes into x minus y, x plus y. Meaning if I have, for instance, a squared number 9x squared minus a squared number 16 and a y squared like that, this will factorize into 3x minus 4y and in the one bracket, and 3x plus 4y in the other bracket. And this is difference of squares, how that works. The third type of factorizing that you must be able to do up until matric is called the trinomials. Now I'm guessing you have some sort of steps or method to do this. You will recognize probably that you did something in class that where you had to follow steps where you take the factors of that and some sort of procedure that you follow to get to x minus 3, x minus 2. I have a video, I'm going to make you a video with every one of this in detail. I'm just explaining to you all of the types of factorizing that you can get, so that you first of all know what must I be able to do, and then you can evaluate for yourself, do you know how to do these things? If you know how to do this very well and you can do difficult problems, when I talk about this you're like, oh yes, I can do that stuff, you don't need to go and watch this video. If you see this and you think, okay, I'll follow what you're doing, but I'm not sure that I know completely of this, then you will go and watch the video on difference of squares. If you can't remember the steps on trinomials exactly, you would go and watch the video on trinomials, so you can decide what you know and what you don't, and then go and study the according videos. Just note that you do get easier trinomials like this, which is not that difficult to factorize, and then you get more difficult trinomials. Say for instance, I'm just going to do 2x squared minus 8x plus 4. No, let me just quickly think. I don't actually want to do that. But what I'm going to do is, this is actually a trinomial, can you see, which doesn't need to be difficult because you can take out the highest common factor 6. But you get trinomials like this where you can't take out a common factor, and then there's a procedure that you have to follow, taking both the factors, this one and this one, in consideration, and you end up with say for instance a 2 there in front of the x, and something like this, 2x, yeah, something like that, where you have to have numbers before the x's to accommodate that one. In this case it won't be necessary because you can take out the 2, but sometimes you can't. This is called advanced trinomials. I just want to make a little bit more space here on the side. I'm just going to take out this line here. The fourth type of factorizing that you get is called grouping. Now grouping is just a fancy way of taking out the highest common factor. What happens there is, if I have, for instance, an equation like this, okay, say for instance I have 2xy minus 4x plus 6ay minus 12a. I can't take out a highest common factor because there are none. There is actually a 2 that I can take out as the highest common factor. Let's just change this so that I don't have a 2 that I can take out as the highest common factor. I just halve all of them. So there's nothing I can take out as the highest common factor. I can definitely not do difference of squares or trinomials, because difference of squares needs 2 terms with a difference of 2 squared numbers, which this is definitely not in so many ways. And trinomials specifically have 3 terms. That's the definition of a trinomial, which this has 4 terms. And then if I can't do anything else, what I do is I divide it up into 2 little problems, where in the first problem I go and take out the highest common factor x, and in the second problem I go and take out the highest common factor 3a. And then usually in grouping, if you take out partial highest common factors, what is left in the brackets will be another highest common factor that you can take out, and you take that out and you're left with x plus 3a. Right, I take out this one and then that's left. Okay, so this is grouping. And then the last type of factorizing that you must be able to do is actually 2 things that compares to this. It's just the difference of cubes and the sum of cubes. The sum of cubes and the difference of cubes, which is the same, where this one is the difference of 2 squared numbers. This one is the difference of 2 cubed numbers, and this one is the sum of 2 cubed numbers. And like there, where I have a basic rule that I follow, this is a basic rule that you follow, that you need to know, where the rule for sum of cubes looks like this. Plus minus plus. And the rule of the difference of cubes looks like this. And if you want to quickly learn the rule and you feel you don't need to really look into this a bit further, I can just quickly show you this rule. I take the cube root of both of these numbers there on top and put them there with the same sign, and then this sign is different than that for both these. Can you see the cube root? And then with the same sign, and then whatever sign I have there, this one is different. So there's a plus, that's a minus, this is a minus, that's a plus, and the second sign is always plus. And then for the terms in the bracket, which is the same, can you see? The first and the last term, I just square this one and that one. So this one squared comes in there, this one squared comes in there, and these 2 terms multiplied with one another comes in the middle. And that's how I remember this rule, and for the sum and the difference of cubes. Right, so this is all the types of factorizing that you need up until the end of matric, that you're going to use and everything that you need to factorize will be some sort of variation of this or a combination of these types of factorizing. They won't ask you anything else. So as long as you know how to do these, and I said this before, if you don't know how to do any of these, please go and check up on them. Please go make sure you know how to do them. There's separate videos for every one of these, so you can go to the video of highest common fact, taking out the highest common factor. If this is something that you struggle with, you can go to the video of difference of squares, of trinomials, of grouping, of sum of cubes, difference of cubes. Right, I just want to give you a few pointers if you're doing a mixed exercise with various types of factorizing. How do I know what to do? Which one of these must I use? Now the highest common factor, you must always first check if you can't take out the highest common factor. That doesn't matter what the factorizing problem is. You must always go and see if you can't first take out the highest common factor. The difference of squares is specifically two terms. That's how you will see it. It's usually two terms. Not usually, it's always. You see it by it's two terms, and there's a difference between them, and those are both squared numbers. So things that will give away is if it's like 100 or 64 or 36, those are all squared numbers. Have a look out for numbers that are maybe doubles of squares, like say for instance 8 and 32, which if you halve them give you 4 and 16, which are squared numbers, and then that means I must just take out a 2 to the side, and then I'm left with 4 and 16. Which I can actually also take out another 4, leaving me with 1 and 4, and 1 and 4 are both squared numbers. But difference of squares, two terms, squared numbers, and a negative in between. And they are similar to these ones. These are also two terms, but how you know which one it is this is a difference of squared numbers, and this one will also have a minus in between, but it will have cubed numbers. So look out for numbers that are cubed, then you must use this, and look out for numbers that are cubed with a plus in between, then it's the sum of cubes. There is no sum of squares rule, so if you have two squared numbers added to one another, you can't factorize that. The trinomials are always three terms, so if you have an equation with three terms, the only thing you need to look out for first is, can I take out the highest common factor? If not, then you follow trinomials for this one. And the grouping is usually 4 terms, but it can be 6 or equal amount of terms also. It's usually 4 terms, and I can't take out a highest common factor throughout, and then I'm left with 4 terms that I have to go and group. If you have, for instance, 6 terms, you might have to group them in groups of 2, 3 groups of 2, or 2 groups of 3. So that's also something to just watch out for, and see if you can maybe group them in 2 groups of 3 that you can factorize, or group them in 3 groups of 2 that you can factorize. And that's how you know which type of factorizing to do. These are all the types of factorizing. You can go and explore them individually in the next videos.